Okay, so quick video talking about standard deviation. Now, you can see here one particular formula for finding standard deviation of a set of data. There are other forms, and you'll see other videos highlighting some of those, but I'm just going to go through a very quick example using this particular method here. So we're going to look at a very small sample of data, so I'm just going to pick some numbers. I'll try 1, 3, 5, 7 and 9. And then we'll find the standard deviation of that sample. Okay, so we're going to use this formula here. So one of the first things I want to pick out is this x bar. Now typically x bar does what? Well, x bar denotes or tells us the average or the mean of a sample. So I need to work out the mean of this sample, the average value. So how typically would we do that? Well, we would add them all up and then divide by however many we had. 1, 2, 3, 4, 5. If I add these numbers up and divide by 5, I'll get 5 as my x bar, my average, my mean. So we now have this thing here for this set of data. What I want to do to make this easier to see what's going on is create a table. So I'm going to have some headings, if you like, and I'm going to have x, where x is just my number. So x1 would be the first number, and x2 would be the second number, and so on. So I have 1, 3, 5, 7, and 9. And if I look in my red formula here, I now need to do each of the individual x's, take away the mean. I'm looking for the differences, how far away all these numbers are from the average. So my next heading is x minus x bar. So it's 1 minus 5, it's 3 minus 5, and so on. So 1 minus 5 would be minus 4, 3 minus 5 minus 2, and then 0, 2, and 4. Now, at some point, I want to be able to get some totals. So I might say, well, what if I get the total of these? So if I add these numbers up, I get a grand total of 0. And that's not just because I've picked these particular numbers. Whatever values I pick, the total here is going to be 0. So that's why, if we look over here at the formula, we have a square, and then later on we have a square root. It seems like they're cancelling each other out, but we have to have a square, otherwise we'll always get zeros for our total. So we're getting there, we're almost done. The next thing to do is to look at the squares of these. So minus 4 squared, minus 2 squared, and so on. Now if we find the grand total of this set, we get 20, and we get a grand total of 40. Now here's the total. Well, we could have said this is sigma of x minus x bar squared, where sigma just means the total of, the sum of, add them up as we go through. So if I rewrite this formula in black that we had in red, my numerator, the top line, is just the total of the differences between x and x bar squared, which turns out to be 40. So I get 40. 40 divided by n minus 1, where n is how many in the sample? 1, 2, 3, 4, 5. So n minus 1 is 4. So if I tally that up, I get the square root of 10. That's my sample standard deviation. I could go to a calculator, I could work it out correct to so many decimal places, I could say, I think that's a perfect answer, I'll leave it alone. It turns out to be approximately 3.16 to a couple of decimal places. And that's the sample standard deviation using this particular method. And there are others, but I think with this method, hopefully you can see that it starts to highlight what's actually going on. We're looking at how far each individual number is, if you like, away from the middle. We can't just add them up to get an overview because we'll get 0 and we'll get 0 every time. So our way around this, our play around this, is to square all our figures, but then of course we have to square it when we finish to get back to the same units, whatever that may be. Okay, thanks a lot.